Captain Peter Cutsey, South Korea, and this is part two to accelerate, decelerate VMO, MMO. I took a little break from part one, still the same night and still the same day, but a little darker. We are established on the 182 radial of the Busan VOR, as we talked about before, at 250 knots and 15,000. Before we actually get into the acceleration and deceleration procedure, I want to point out what we're looking at again on the map. And any time as a point of interest that you're working with a radial on a VOR, you should check raw data. So if we go to the approach selection on the EFIS, which we've just done, you'll notice that we are actually on course. We've got the VOR, the PSN VOR tune 114.0, and you can see that down here on the nav display. All right, and we're 26.7 nautical miles, and it's tuned on both number 1 and number 2. So it's very important that you actually check that to make sure that the map, in fact, is correct. And our map is correct because the raw data, which is the information directly from the VOR, overlaps the computed data on the map. All right, so let's get right into it. We're going to go to the MCP, Remote Control Panel, and we're going to increase our speed to a commanded of 340 knots. There it is up here, the commanded speed. If you notice, the thrust is increasing. And the speed is increasing. We've punched our clock, and we're looking at a time. Here's the HUD. The commanded speed is here, 340 knots. We're only 270 knots. That's why we have this long pillar below the left wingtip, which is an airspeed error tape. Yes, it's an error, but we know why it's there. It's because we are not at the commanded speed. So as we are increasing, this is the airspeed trend vector. The next 10 seconds, the airspeed will be in this spot. And if you notice, as we're getting closer to VMO, the pillar on the bottom part of the left wingtip on the HUD is actually decreasing. With the auto throttles engaged, the protection is built in that we will not exceed VMO, MMO. If you notice, the thrust will start decreasing now so that we don't exceed. Now we actually did a little bit, so let's just go back, because it could be a small software. Oh, no, it isn't. There we go. So the autothrottles are doing their job. All right. So what we're going to do is disconnect the autothrottles, as we mentioned we would do before in the briefing, and then go ahead and increase thrust so that we, in fact, are going to exceed VMO. Now there's no protection. Now you're going to have the clacker. Yes, you are. All right. So we'll put the auto throttles back on, return the thrust to idle, and go into the first stage of the deceleration and set the airspeed bug to 250 knots. Boom. Start our timing. So we took our timing. It took 1 minute to accelerate to VMO. Now we'll see how long it's going to take to decelerate to 250 knots. Now, here, if you notice, the pillar is on the top of the wing because the airspeed is higher. The actual airspeed, 309 knots, 8 knots, is higher than the commanded at 250 knots. Wow. And the trend vector, the next 10 seconds, that's what this represents. The airspeed in 10 seconds will be there. By the time we get to the commanded speed, thrust should increase, the trend vector should be minimized to nothing or zero, and the airspeed error tape should also collapse to zero on the wingtip. And you can hear the autopilot trimming. Let's have a boo here. And the trim wheel moving, and the thrust levers are moving. So that's what you would be doing on auto flight. Now the auto throttles are ensuring that the speed is maintained at 250 knots. That took 63 seconds. So good to remember, approximately 1 minute to increase from 250 knots to VMO and then to decrease. About the same time without speed brakes, and we're at max landing weight for the NG, for this series of NG, at 66,360 kilos. All right, now we're going to go to the second stage. If you notice, we're pitched up here, folks, at 2.5 degrees. Each one of these little lines represent 2.5 degrees of pitch. There's the flight path vector. It's right on the horizon. Remember, the flight path vector gives you your flight path. And in level flight, the angle of attack is your pitch. There's our angle of attack, 2.6, 2.8. So that's what we have here, 2.6, 2.8. And there it is on the HUD, 2.6, 2.8. So you have to understand angle of attack. And in my library, in the hundreds of videos I talk about angle of attack several times, especially when we talk about approach to stalls. Okay, so we're going to go into the FMC CDU here. We'll pop over to the VREF. We'll set, pardon for that noise, and we'll set VREF 40, and we did. And we'll come back now to the simulator. So we're going to now take the auto throttles off and again and take a timing and see how long it takes to decrease our speed from flaps, from 250 knots, I should say, to flaps up speed, which is 212 knots here. So starting the clock. The auto throttles are off. Trend vector, the speed trend vector slowing. And here again, below the wingtip, the pillar for the HUD, because we're not at flaps up speed yet. Then you can hear the stabilizer trim trimming. So we'll pause the simulator. There we are at flaps up speed. We checked our timing. And if you notice, the pitch reference now is very close to, well, 4.5 to 4.5 degrees. There's the angle of attack, 4.5 degrees. All right. So this is in effect what your instructor will be doing with you if you're taking an initial type rating course in the simulator, and that's exactly what it looks like. So this will complete part 2 of the accelerate, decelerate, VMO, MMO, and I hope you've enjoyed the video, and see you in the next one. This is Captain Peter Cutsey in South Korea. This is my briefing room.